In this opportunity we are going to study the digital scroll compressor that works with R410A refrigerant gas.
1. It is a scroll compressor, positive and orbital motion. 2. Suction and compression are. They are achieved through the action of two spirals, one fixed and the other mobile. 3. It is a hermetic compressor. 4. It is considered a high-efficiency compressor. Let's start by saying that the digital compressor is a scroll-type compressor that can regulate its cooling capacity by separating the compression coils with the use of a solenoid, thus generating considerable energy savings, especially on those occasions where there are cooling loads. Variables, for example, in air conditioners that work day and night or that are installed in premises where the number of occupants changes. Observing the animation that we are showing on the screen, we can notice that at times when the cooling capacity of the compressor exceeds the need of the premises, then the separation of the spirals occurs vertically. This separation is caused by a solenoid. In addition, we can notice, although the spirals separate, the motor does not stop, avoiding unnecessary starting peaks. Features of Copeland ZPD and ZR 10% of the nominal capacity of the compressor, thus allowing a precise control of the temperature, greater comfort and energy savings. 2. No complex electronic modules required. It is a practically plug-and-play solution that enables fast installation and easy maintenance. 3. The speed of the motor is constant since there is no variation of the control, whose strategy is based on pulse width modulation. 5. For example, if the system uses a 12-second duty cycle, this indicates that the solenoid is cycled on and off every 12 seconds. 6. In a digital scroll compressor, the motor continues. It can supply capacities between 10 and 100% simply by loading and unloading the coils at successive regular intervals. 8. The modulation principle is mechanical, therefore, that the algorithm used by the electronic controller is much simpler. 9. In the systems with digital scroll compressor, there is no generation of electromagnetic interference as in the case of inverters. This makes this technology ideal for critical applications, such as computer centers, telecommunication centers and hospital.
Now we are going to study the working pressures handled by the digital scroll compressor that works with R410A refrigerant gas. Go ahead, Paco, with the explanation.
On the screen we have the tables of pressure and temperature of the refrigerant R410A. Work high. Mostly R410A is used in air conditioning equipment. Let's observe the pressures present in these equipments. 1. Low pressure for a temperature of. Here we have an absolute pressure of 136.93 psi. To know the low or evaporator pressure, that would mark the manometer, we subtract the value of the table, the atmospheric pressure. This way, you get 136.93 psi minus 14.7 psi. This subtraction results in a gauge pressure value of 122,230 psi. 2. To know the high pressure of a team that works with R410A, you get a value of 50 degrees Celsius. Here we have an absolute pressure of 439,515 psi. To know the high or condenser pressure that the manometer would mark, we subtract the atmospheric pressure from the table value. This gives 439.515 psi minus 14.7 psi. 3. Air conditioning pressure, being off. For a room temperature, again 35 degrees Celsius, about 95 degrees Fahrenheit. Here we have an absolute pressure of 309,626 psi. To know the pressure of the equipment, being off, which the manometer would show, we subtract the atmospheric pressure from the table value. Thus, 309,626 psi minus 14.7 psi is obtained. This subtraction results in a gauge pressure value of 294,926 psi. Since the equipment is now turned off, both the high and low pressures would read the same, with a value of 294,926 psi.
Remember that in the description part, there are links to find additional information.